This video summarizes what we discussed about the accelerated motion, in particular the projectile or free fall object today in the class. Object that is in free fall, you always have a acceleration that is constant. It's like a 9.8 meters per second square. What does that mean is that its velocity or its speed will increase downward each second, 9.8 meters per second each second. Therefore, remember, 9.8 meters per second each second. Therefore, it's 9.8 meters per second squared. Therefore, in this question, the correct answer is D, increasing speed and constant acceleration. All right, once again, neglecting a resistance, a ball is rolling down slope steep, and that way it only get a portion of the gravity. And then, of course, actually gravity is at work, is increasing speed and constant acceleration. So, but it's smaller than A, smaller than G. Okay. How strong the gravitational acceleration is projected along a inclined plane is dependent on the angle or the slope of the thing. For example, if the angle is theta, the acceleration along this steep hill is equal to sine theta. It's a trigonometric function times g. Recall that when it's flat, the theta is 0, and then you get a 0 projection. And when you go up a little bit angle, and it will be have some value. Then when it's 90 degree, a sine of 90 degree is simply 1. Therefore, you have a full free fall. On the third question, and a ball throw straight up and come to a momentarily stop at the pass. What is the acceleration of ball during this stop? And once again, the gravitational acceleration for the projectile or something floating in the air, and it's always exists. So it's 9.8 meters per second squared. At the top, even though the velocity is 0, the acceleration is still 9.8 meters per second squared. Okay, and it is that velocity acceleration that make the velocity reduce to 0 and then accelerating downwards. Then we discussed the velocity versus time function, and for the uniformly accelerated motion. So velocity as a function of time is simply equal to AT or GT in the case of gravity. So that G value is always 9.8. So that's this precisely. If you want to make a plot, and you simply have to go using a chart representation, and for example, this 1 second is 0, 2 seconds is 9.8, and so on. That's the table representation or function. And if you want to use the graph to represent the function, you just have to use the table entry as the ordered pairs and do the plot. So you have a linear relation. In other words, for the gravitational acceleration, and the velocity or the speed just increase with the time linearly. So you have that. We applied to a slightly different situation. If you push a ball down, which means you are giving a velocity, the object a startup velocity or initial velocity, then the velocity changing with the time is different. And then, of course, simply you just have an initial 5 meters per second, and then that's the formula representation of the new function with an initial speed in the same direction as the gravity. So then that's free fall. And the second one, you will have starting value, or you can say that's the y-intercept, and then you will have the gravity to be, the function to be just right above that. So then here is the table. Important point is that 0, you have 5 meters per second. And then, of course, that 5 is always there. You just keep on adding up. So another interesting situation is that you're still choosing downward to be the opposite direction. And if you this time you toss the ball up, but and if you say downward is the positive, the 5 meter per second up above is -5. Then you will have this as your velocity versus time function. You start it from here, and -5, and then the gravitational acceleration is positive, so it will make less and less negative until it reaches 0. That's when the object reaches highest points or apex, and then start turning down. That's the positive direction. So if I ask you a question, how long does it take for the object to reach the top? From this graph, you just have to look for how long time it reaches from a negative velocity and to a 0, and then to positive direction. That 0 point is where an object is turning directions from upwards to downwards. And then in this particular case, you will say, well, at roughly 0.5 second, half a second, object reaches top. All right, so this is, once again, it's velocity versus time function, and it is Vt, okay, and as a function of time is simply equal to At. A is the slope, and T and is the independent variable, plus a initial velocity where there is a plus or minus, which is denoted in general. That's the beauty of algebra. Okay, it could be positive, it could be negative. This way cover everything. Okay, we will continue explore more about velocity versus time function and in accelerated motion, and also the distance or position versus time function. In that case, which is a quadratic. Important to know what question, what quantity, which function we are talking about. Don't just simply say, well, free fall is simply linear, or free fall is simply quadratic, but depending on what you're talking about. If you're talking about velocity, it is a linear function, and the slope is the acceleration. But if you talk about the position, it is a quadratic function. There is no fixed slope because it is a curve. So the acceleration is the first term, and is on the t squared term. Okay, and so I will see you next time. So in summary, we talk about this velocity as a function of time, as a linear function.